Okay, welcome back again. So I'm going to post that other video separately. I'm going to call it the assignment 2 discussion so that everyone can understand that that's what the purpose of that video was for. This video, we're going to go ahead and move on into the abstract classes and interfaces discussion so that you can have an understanding of Joseph O just said on assignment 2 that we needed to make person abstract. I don't know what that means. Well, now you will. Okay, so, all right. So some objectives of what we're trying to do is, the idea is, you know, we created these classes and these parents and child classes. But what if the parent is this more, it's abstract, it's a concept. It's a concept of something that we want to create, and we want certain things to be true of anything of this type of thing. But we want to force our programmers who might use our classes, we want to force them to actually make something that's concrete. We want to force them to make something that's an actual one of these things, right? What we can do is we can then create this thing called an abstract class. So know that circle is a geometric object. Rectangle is a geometric object, all right? But if I were to say, I want you to make me a geometric object, just do it. Make me a geometric object. What is a geometric object? Well, what defines a geometric object? Well, I mean, it has sides. Well, a circle doesn't have sides. No. What else? I don't really know, right? Well, it's got some stuff in common. Well, does every geometric object have area? Yeah, every geometric object has an area. Does every geometric object have a perimeter? Yeah, well, for circles, we call it a circumference, but yeah, it has a perimeter. So there's certain things that it has in common, but if I were to say everyone in the class draw a circle, like, you would know specifically what that meant, right? Some of you might draw something that's not a circle. You might draw a rectangle, but that would be wrong. If I said draw a circle and you drew a rectangle, you would know that's wrong, right? But if I were to say draw a geometric object, well, suddenly now it's not as concrete, is it? It's not specific, right? It's more abstract. But the idea is that there is still things that every one of them has in common. So we might want to force our programmers that are wanting to use our classes to create a particular type of geometric object of whatever they want, but we still want to have something that is something that kind of is a general definition that all geometric objects have in common. So in the example for the for the assignment 2, right, I said that you needed to make the person class abstract. So what I'm saying is that I want to be able to have this idea of a person, right? A person that has certain things in common. But as far as our university system is concerned, we don't want to just be keeping track of any old person. We want teachers and students and grad students, you know, and in a real university system, you might even include as part of that staff and secretaries and teaching assistants and other things, right? But you would have this person class that, as far as the university is concerned, nobody can be just a person, right? They need to have some role in here. Okay, so basically that's how to understand what an abstract class's purpose is. Okay, now there are some things that we can do. Oh, one thing here, also notice that abstract methods can be part of an abstract class. Now what this means is that we can say there are certain methods that just exist for all any object that's going to be a child of this class, right? There's certain methods that we want all of our children to have. We want all geometric objects to have a get area method. We want all geometric objects to have a get perimeter method. Now, how those get defined by the subclasses, by the children, might be different. A circle's area is going to be very different than a rectangle's area. A circle's perimeter, or for a circle they call it circumference, and a rectangle's perimeter is going to be very different. How we calculate it, right? But they still both have them. And what this is telling us is we can create a method, kind of like a method stub for both of these methods here. And the circle and rectangle will say, we expect you to tell us how to implement this for you. Okay, we're going to tell you that you need to implement it. You are going to make it happen. Okay, now an abstract method cannot be inside of a non-abstract or what we'll call a concrete class. If a class is concrete, meaning it does not have italics, so you notice the abstract class name is italicized, italics, same thing with the abstract methods, right? An abstract method cannot be in a concrete class. And if a subclass of an abstract superclass, so if the circle class does not implement an abstract method, we'll get a compiler error. Right. Or the subclass also must be defined as abstract. Okay. So any concrete class must have all concrete methods and must implement any abstract methods of its parent. Okay. Because remember, one of the things we talked about before was that when a class inherits from a parent, uses that extends keyword, when a class inherits from a parent, all the methods of the parent get kind of, in a sense, copied to the child, right? Well, if an abstract method gets copied to a child, it doesn't have a definition. We have to define it. We have to tell it, this is how to make this method happen, right? We have to make it concrete. If we don't, then we have this method that doesn't have a definition existing in a class, okay? And all abstract methods from an abstract class must be implemented in its child class if it's not abstract, okay? We cannot use an abstract class using the new operator, so we cannot create an object of an abstract class. So we have constructors for them. We do have constructors for them. We can, right? But only as far as maybe we want to invoke them from the child. So we have a constructor for geometric object that's used by the circle class to create a circle. Okay? But we cannot create an object of type geometric object. And this is going to get a little bit confusing if you're not paying attention. Okay. The reason why is because even though we cannot create an object of a certain type, doesn't mean we can't have a variable of that type. Okay. There's some examples of that, and we'll talk about that in just a moment. Okay. So a class, if a class contains abstract methods, it must be abstract itself, but an abstract class could also contain non-abstract methods. Okay. A subclass can be abstract, even if its superclass is concrete. Okay, even if its superclass is not abstract. Okay. So for example, the object class is concrete. You can create an object of type object, but the subclass, geometric object, is abstract. And in fact, every possible relationship could exist. You could have a parent, so object is concrete, and every class, abstract or otherwise, inherits from object. So a concrete class can have abstract and concrete children. Okay. An abstract class, such as geometric object, can't have abstract children and concrete children. All right, so every possible, you can have abstract, 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 non-abstract, all four. Okay, all four combinations are possible. Okay. Okay, I won't talk too much about this, about the concrete method being overridden, because generally that won't really happen a lot, but it's, yeah, anyway, it doesn't happen a lot. It's not really all that purposeful. Okay. All right, so here, since we cannot create an instance, but you can use it as a data type. Okay, so notice that we're not creating any objects of geometric object type. We're creating an array of memory locations that will hold geometric objects. Okay, this is where I said this would get confusing if you weren't paying attention. Okay, this is the important part. I can create an array to hold geometric objects. I can create a variable that I'm going to say points to a geometric object. What I cannot create, what I cannot make, is an object of type geometric object. All right. If I take this array and put some objects into this array, or if I were to have a geometric object, obj equals new rectangle, right? I can take a variable that's a geometric object and point it to an object of some subclass of geometric object. Okay. All right. I may try to show that using the whiteboard in just a moment. All right. So we've talked a little bit about these different number types. They are all subclasses of the number class, and the number class is abstract. And notice that these right here are all abstract methods that exist in these different subclasses, and how they're implemented is different. How they're implemented in each of these is different. Okay. There's some other abstract classes that are useful, like the calendar class. Calendar can be useful for using the date, right? To be able to do logging and stuff like that. Okay. I'm not going to spend a lot of time on the calendar class, but if you want to, you can. Okay, you can go back and look at that. All right. An interface is like an abstract class with some very, very key differences. Okay. One is that an interface is like a class in that it contains methods and it contains constants, but it can only contain constants and abstract methods. Okay. But the difference is that since there's only abstract methods and only constants, then it's like trying to help understand the common behavior of an object, of a potential object, instead of defining common attributes and common other things. All right. Such as comparable, clonable. In an example we'll look at in just a moment called edible. Are two things edible? Or is something edible that may not be both of the same parent class? Okay. So for example, this is instead of public class something, we call it an interface. Public interface, whatever its name is. Same rules apply as a class name, so capital letter first. All right. We can have some constants and abstract methods, and anything that inherits from the interface is going to, just like with the classes, it's not extends, implements. Anything that implements the interface is going to have to make concrete these abstract methods. Okay. So again, interface is a special class. Right. So if we look at an example, let's look at a specific example. We have an edible interface that's going to say, okay, for each of these, we're going to eat it somehow. All right. Because if it's edible, we need to eat it, or we can eat it. Right. And then we also have this class called animal, this abstract class called animal. Now, the way that we say that a class implements an interface is with this dotted line with this with the triangle. Similar to the inherit, similar to the extends, all right, but instead of a solid line, it's a dotted line. So the way that we would look at this and the way that we would read this is that a tiger is an animal. Yeah, that sounds right. Yeah, that's good. All animals have a sound, right? So we cannot create an object of type animal. We can create an object of type tiger. We can create an object of type chicken. All right. So a chicken is also an animal. Yeah. Okay. But a chicken is also food, right? So a chicken is edible. Right. Now a fruit, it's not an animal, but fruits are also edible. Okay, even though my son doesn't eat them. All right, but they are edible. And the fruit, well, we'll call that an abstract class because really we want to say if you have a fruit, it's got to be something. It's got to be an orange, an apple, a banana, a pineapple, a star fruit. Some, it's got to be something like an apple and a banana aren't the same thing, right? So got to say what fruit is it? Right. So even though a fruit is edible, just like a chicken, a fruit is not an animal like a chicken. So again, in a sense, this is going to try to get particular attributes and behaviors from this class, but it's also going to have stuff from this interface. Okay. All right. So notice that chicken can kind of say, oh, I want to get stuff from both of them. And that's possible using interfaces. So we'll look at this example. I'll put some examples up in just a few minutes. Okay. Now, we don't have to put the public abstract, the public static final modifiers on interfaces because all attributes of an interface are public static final. All methods of an interface are public abstract. Okay, so you don't have to. These are the same. We don't have to do that. Okay. We will look at we will if we have time look at the comparable interface because this is a very important interface. It's one of the interfaces that we can use to be able to compare two objects of a same type. This is useful for being able to put them into an array list or an array and sort them. Right. Basically, what compare to does is that if the thing being compared to the thing being passed, if the thing being compared is greater than this, whatever we define greater as, we will get a positive number back. If they are equal, whatever equal is, they will get 0 back. And if the thing being compared is less than whatever is being passed, then the return value will be a negative value. Okay. So if we wanted to compare two different geometric objects, we can do that. We can compare that based on their area. We could compare it based on their color. We could compare it based on their type. All right. There's all types of ways that we could compare two things to each other. In the same way, it's like when I have a list of all the students of this class. All right. I might want to sort you by your name. I might want to sort you by your student number. I might want to sort you by what year you are, if you're the first year, second year, so forth. Right? So I could redefine the compare to method to simply say, oh, I want compare to mean by student number now. That if student number A is greater than student number B, then pass back a positive one, right? Okay. So that's the way that the compare to can work. All right. I don't want to do a lot with this stuff here. Although I do want to go ahead and show this now that I think about it. The different classes and how we can tell what is the parent class and what is an interface that it implements, that it uses. Right? So notice that because these all implement the comparable interface, they must override the compare to method from that interface. Okay. So it extends a parent class, it implements an interface. All right. All right. So some different examples. Integer 3 compared to integer 5 should give us a negative number because it should return a negative value because 3 is less than 5. ABC compared to ABE should give us a negative number because ABC would be considered less than ABE. Right. Date 1 is greater than date 2, so it should give us a positive value. I think these examples are available in the lecture examples, but we'll take a look. Okay. So again, we're going to come back to the an idea of the whole instance of. Right? Is in instance of integer true. In instance of object, true. In instance of comparable, true. Right? So instance of is not just about what parent class you extend, but it can also be about what interfaces you implement. So in this case, all of them extend from object on some level. All of them implement the comparable interface. In instance of integer is true. In instance of string, not true. It's false. S, instance of date, would be not true, would be false. But S, instance of object, instance of comparable are both true. Okay. All right, so instance of can be used to tell me not only what class I extend from, but also what interfaces I implement. Okay. And so we can have something like this. So we could say, hey, you know, we want to have a geometric object. We want to have rectangles that are geometric objects. And we want to have some special rectangles that are comparable, that implement the comparable interface. That's possible. That's great. Right? And we can use that comparable interface to be able to sort things. Won't talk too much about the clonable interface, but the idea is, remember one thing that we we talked about how when you said if you had an object of whatever type, and you had a variable called a, let's say, and you took a and you assigned it to an object, and you took b and you assigned it to a new object, then you said b equals a, that wasn't the same as copying a into b, it was making them both point to the same thing, right? The clone allows us to be able to create a copy and be able to do it that way. Okay, we still can't do the a equals b, but we can create a clone of an object so that we can create a copy of it for use to be very easily to be able to assign it to a new variable. Okay. All right. Like I said, I don't want to spend too much time on this one because it's more it's a little bit more advanced than I really expect that you guys should need to know for this class. But it is something that if you're interested in this whole idea of being able to create a clone of something and put it into the new variable, then we can do it that way. Okay. One thing though is that we do have the difference between a shallow copy, where any reference variables in here that point to the same thing, they will always point to that same thing. Okay, whereas a deep copy will also make copies of the reference variables as well. So a new date, these point to different date objects. Okay. All right. So a few differences: interfaces versus abstract classes. Right. So an abstract class can have any type of variable. They can be public, they can be private, they can be protected, they can be static or not static, final or not final, whatever. Right? No restrictions on an abstract class. In an interface, all variables are public, static, final. Abstract class, they have constructors. Now, we cannot create an object of the type. We cannot create an object of the type of an abstract class, but we can still have constructors so that when subclass objects are created, we can use that constructor as part of the process. Okay, so we cannot use the new operator on an abstract class. Okay. An interface, on the other hand, no constructors at all. We do not create any type of objects from interfaces. Okay. Methods in an abstract class: abstract, non-abstract, public, private, whatever. Right? Methods can be anything in an abstract class. In an interface, they all must be public and they all must be abstract methods. Okay. All right. All right. Some just different how to understand the instance of stuff. So if we had, let's say, class 1, it is an instance of object. It's also an instance of interface 1. It's an instance of interface 1_1. It's an instance of 1_2. It's not an instance of anything over here. Okay. In the example they give us down below, C is an instance of class 2. So if we were to do C instance of any of these, we would get true. C instance of object, true. C instance of interface 2_1, true. C instance of interface 1, true. For all of this, okay? So as far as the instance of operator is concerned, doesn't matter whether it extends or implements. If it does either of those into anything that those parent classes and implemented interfaces, anything that they inherit from, also counts as what this guy is a child of. Okay, it counts as an instance of. Okay. There can be some conflicts. Okay, let's say that we implement two different interfaces, and they both have methods with the same signature. So, void P with no parameters, whatever. Okay, and Or maybe two methods with the same signature but different return type. All right. This type of error, if it has the same signature with different return type, or two different constants with different values, so the same constant name but two different values, the compiler will detect that and will give us a compiler error. Okay, so we cannot implement two different interfaces that come with conflicting information. So then you may be asking yourself, well, should I use an interface or should I use a class? Well, what do you think? Basically, if you're wanting to say this is a very strong is a kind of relationship, like this is a whatever, like a student is a person, a teacher is a person, right? Then that's really going to be a parent-child. That's going to be an extends type of relationship. If, on the other hand, you are thinking, you know, it kind of describes similar behavior. Both of these things should be comparable. Both of these things should be, edible, or both of these things should be purchasable, you know, or something like that. Like a house and a computer, you know, two different things that you can buy, right? Then you might then want to have an interface for that. Okay. And let's move on. Trying to decide. Okay, so if you were designing a set of classes, right, a class should describe just what is a single thing and anything that kind of goes together, logically fit together. So we could use like a class for students like we do in our assignment 2, but you might not want to put students and teacher in the same class. That's why I put them as separate classes, but they both inherit from the person class, right? Because both students, you guys, and teachers, me, we're people, right? We are a person, or I am a person, you are a person, right? And so by the fact that we are both people, there are things we have in common. We both have an ID number. We both have a name. We both have an email address. In the case of the assignment, we both have a department that we belong to, right? And so those are the things that we would put into the person class. And then the subclasses, the child classes, the teacher and the student class, that's where we put the stuff that's specific for that that type. Okay. All right. And I think that's really all there's some more slides in here, but let me see here. Well, I guess, yeah, let me finish off this next few slides and then we can take a break. I will stop the recording and I'll come up to the next recording for some examples. Okay. All right. So one of the main things is that classes are designed for being able to reuse the same stuff for different objects. Okay. So you might want to have certain things that would exist for all objects of that class. Okay. Now, one thing is that you should, whenever you're designing a class, you would want to create a no argument constructor and override the equals method and the toString method from the object class. Now, notice that we did not do that. We did not do the override the equals method for our assignments, but I did have you override the toString method. All right. How would you define equals? Consider how you might define the equals method for the teacher class, for example, or for the person class for that matter. All right. That would probably be something that you would want to do when you'd be designing a new class. All right. Just like before, we talked about with variables, you want to have good names for classes, attributes, methods, right? And provide constructor and initialize variables, right? Because if you end up with a null value, you can end up with problems. Using visibility modifiers, we've talked about this, about making sure that ideally what you want to do is make your attributes private and your methods public, right? But you, and that's generally a good rule of thumb, good practice, right? And then one other thing, any property that's shared by all instances of class, we can declare as a static property. And then that way it doesn't create multiple variables of the same type for different classes, for the different objects, if one is good enough. Okay. All right. So that concludes our discussion on the slides. What we will do now is, like I said, I will stop this recording. Please contact me if you have questions. But what we'll do is we'll stop the recording there, and I'll restart the next recording to show examples. And if I can find it, I'll do a whiteboard style stuff. Okay, because there's some stuff I want to show you as regards to the abstract classes. All right. I guess for me it'll be a little bit, but for you it'll be just a second until the next video. All right.